Many just the hardware players are claiming that they are deploying the real world spaces, but it's not real world. It's like a lab. They are still just dancing, kicking.
The problem itself should come from industry. The definition of dexterity should also come from industry.
What kind of tasks are very important from the industry?
What's the difficulty? Even though the industry tasks is like totally different, but there are certain, maybe common, 5 to 6 different challenges.
We analyzed 5-some thousand pieces of the task. We found that 18 core tasks, they come out like over and over.
It actually just became the foundation of our DexBench.
So, hi, today we are talking about DexBench. It is a dexterity benchmark built for robot hands. My name is Jacey. I'm working on technical strategy at RLWRLD. So we have Henson and KW.
Hi, my name is Henson. I'm the Chief Strategy Officer of RLWRLD.
Hi, my name is KW. I'm a Chief Business Officer.
So we are going to talk about what is DexBench. So before we get into details in DexBench, I think the industry is now laser focusing on the dexterity. Why now we are having a dexterity war? Henson, maybe?
A lot of companies were trying with two-finger grippers and a lot of different methodologies, but there's a clear limitation because all of our surroundings, all the tools, all the objects are all designed around the human hands, 5 fingers. It cannot use most of the human tools that human use in the human manner. We actually built this DexBench,
Right.
Because there's no standard measuring dexterity, and there's no definition of dexterity either. The reason why we need this kind of DexBench is that all of the foundation models, like robotic foundation models and a hardware development is for just one thing: deployment.
Deployment.
Yeah. And deployment it means deploying into the industry. So the problem itself should come from industry. The definition of dexterity should also come from industry. So that's why we started from the industry problems. We broke it down into more than 5,000 pieces. We actually derived that even a very complex looking tasks are made up of combination of only 18 key atomic tasks.
So what's interesting is if you see frontier demos from physical intelligence or Sunday robotics, they still focus on laundry folding. So I think the laundry folding would be the best case for the households. And I wonder what kind of tasks are very important from the industry. Can you make some examples of the tasks?
Of course. So handling different types of package parcels from the conveyor belt and rearrange it and make it flow. Those kind of actions can't be done with two-finger grippers, and it actually requires the dexterity. It requires multiple fingers, how to grip the object in the right way, and the reorientation of the objects. Those things are all involved in the DexBench, and also these are the things that we should measure, how fast and how well it performs is the key.
I think so. We also got lots of endorsements from the industry. KW, maybe you can name some those customers who endorsed our DexBench.
So from the inception of the real world, we actually had conversations with more than 200 large enterprises in Japan and Korea. So manufacturing and then logistics, retail, and then hotel services. At the end of the day, all the companies should generate some proper revenue and the proper profit, right? So we actually started that journey together with our model development journey, right? When you just first discuss with the CEO of the large manufacturers or just the large retailers, right? It's 2 years ago, when we just start this journey. They didn't understand that much about the humanoid. And then also, they didn't understand what humanoid can do. And then, it's very simple. It's very simple to just maybe open up this, right, bottle cap from the human being. And then we don't think about it at all, right? But for the humanoid, right, this is a very difficult task. And then we don't know exactly why this is too difficult to the humanoid. And then we didn't have any just language to explain that. Any just theory to explain why this is like a simple task is difficult to feel humanoid. Right? When you just maybe discuss with like those the CEO and then executives in the large enterprises, I need to just persuade them that we are the partners, and then let's just maybe make sure that we can deploy the humanoid in your workspaces. Then to do that, we need to just create some data, and then let's become a partner, and then create some data from your real world spaces, and then build a model together. But to persuade that, we need to clearly deliver when humanoid can do what kind of tasks, and then what's the financial impact, what's the ROI. I needed some clear framework to understand level of difficulties for the humanoid when they do any type of task. That was the starting point of the DexBench. Right? We dispatch our FD in the right. It's different industries, and then identify more than like 5,000 different tasks. Right, that is required in each different industry. For example, hotel. Right, we identified 5,700 different human tasks.
Wow.
Yeah. And then we actually just used fine-tuned VLM and then captured all the human behavior, and then understand it second by second human tasks, and then made some annotation, very detailed level annotation on that kind of tasks, and then would like to just understand what's the level of difficulties of that tasks for the humanoid, not for the human, right? That we needed some certain framework to understand that. And then only with like that kind of a framework, we can just measure this task when can be just maybe addressed by the humanoid. Then we can just create some proper master plan to the enterprise partners, and then give them some proper expectation, right? When we can deploy really in your workspaces. That was the starting point of the DexBench.
Yeah, how's it working out for you?
Yeah. Yeah, it was like a very tough journey, because like creating, so we are all doing the startup, and then it's like a matter of time, and then a matter of the we need to become very efficient in terms of our leveraging the capability and leveraging our resources, so that product market fit is like always most important stuff,
Yes,
right?
of course.
But after we started to look at 5,000 different tasks from each industry, then where should we focus?
Yeah.
And then, each industry player claims that our task is totally different from the other industries. And then you need to create some very customized solution for our industry. But if we are changing all different industries, and then all the different framework, all the different maybe engineering challenges, then we cannot make any further steps, right? So that I wanted to create some really great product market fit. And then once we just understand those kind of tasks, we started to realize that even though the industry tasks is like totally different, but there are certain maybe common 5 to 6 different challenges, 5 to 6 different physics challenges in those kind of tasks. So that was the maybe starting point of that. We created OSC and then Dexterity framework. Right?
Yeah.
That actually just became the foundation of our DexBench, right?
OSC is like, that's the pinnacle of the whole system, right?
So what was the OSC? Was it like object state complexity?
Yes, it's like object state complexity. And then one day, because I spent many hours with like the RX consultant and then business teams, and then they were just yelling me that KW, we are talking to many different industries, and then we cannot just follow all this kind of stuff, right? We have some limited resources, and we needed some certain framework how to prioritize these kind of opportunities. And then that was actually starting point. And then after I discussed with like many engineers and then the business people, that I spent one weekend on a table, and then started to think about that. And then we've spent some time, and then created maybe the first foundation theory about this OSC and Dexterity framework, right?
But
yeah,
you
yeah.
shouldn't say that like it was like it came out just from like a one weekend.
Yeah, it's like I had a very tough times with like more than like 6 months
Yeah.
without the.
So I want to walk through like, what kind of tasks we gather from the industry with this OSC framework.
So he's the father of OSC and the Dexterity regime. So it's like a both like a top down and bottom up. So from top down, there's OSC and the Dexterity regime,
Right.
and from bottom up, we very like in the very detail we analyzed all those like sources from
Yes.
our robotics transformation team, and from those like 5,000 pieces of the task, we found that 18 core tasks they come out like over and over.
Right.
These
Across the industries, right?
across the industries, and they're like a really penetrating
That's right.
tasks across the industries, and like for instance, like precision insertion, right? We plug in USB connectors, and even like there's a box, we put it like in a very detailed like insertion, right? So these kind of things happen over and over
Sure.
in every especially manufacturing, logistics and services.
Yeah.
They're coming out like over and over. So this is like one example of the 18 key tasks. And if we solve these problems, then I guarantee that about 80% of the things that is happening in the work site can be solved with the combination of these tasks.
Yeah.
Yeah, I feel like that gives us a very good direction for our the business activities. At the same time, our the model development activities, right? So I think you might be able to just share some more about our the RLWRLD 1, right, architecture, and then how it is like related to this kind of the Dexterity framework that we create.
Sure. So in order for us to solve these problems,
Yes.
right, the VLA itself wasn't enough. Most of the VLAs, they don't have the memory module. So it doesn't know like whether it is like holding something or not if it is not visible.
Yeah, there's a collision in the hand.
Yeah. If it doesn't know like if it is holding something or not, then we cannot do like most of the tasks with the small objects, right? Yeah, and also if like catching like a moving object, a lot of VLAs have like a very hard time like catching like a moving objects from conveyor belts. To combine and to embrace those different modalities and modules, we designed MSAT.
There's
It's
this
a-
multi-stream action transformer.
Yes. Our model design itself is built around the philosophy of the DexBench.
Yes.
So if you see DexBench right now, we made it our best to make it reproducible and also very structured so that many industries can try this DexBench framework. So at this point, we put like initial state and final state, and then also we define the like failure conditions so that we make it reproducible. So now I think we have to talk about NVIDIA partnership.
Sure.
Because we want to make this DexBench more sophisticated so that in like maybe in simulation. So KW, can you like explain how we're partnering with NVIDIA to make this DexBench?
Yeah, as we all know, there are some many fantastic academic benchmarks like Ribello and then Kelvin, right?
Yeah.
But they gave us some great foundation in the market. But most use cases were like a pick and place. And
Yeah.
as it's just a Henson mentioned, our the DexBench, it's like a reality, right? It's like the benchmarks that should be just deployed in the real world industries. And I feel like NVIDIA team really just wanted that kind of approach. Right? So that there are many frontier labs in the US market who's working on some, that kind of the manipulation tasks with like a humanoid and then foundation model. But all the tasks looked quite familiar to us. And then most maybe use cases quite be done in residential spaces. And then still maybe the many people just to believe that it's still just not in the real world stages. It's like a lab stage, right? So it's not the real world task. So that the thing that we actually just developed that kind of the DexBench from the real world use cases, I think that was the most important point that NVIDIA team really liked that our approach, right? Because everyone, including us and then NVIDIA, all we want is like maybe reducing some time for the deployment, right? So that we need to create some impact, and we need to just see that humanoid is like working in the real world industries, factories, retailers, right? Logistics centers, right? We need to create that moment faster than anyone. Then all the RFM players and then all the hardware manufacturers and sensor companies should be able to look at the same problem and then some need to just maybe tackle the same challenges. And then I think the DexBench could be a very good, right, framework and then guidance for the many different ecosystem players around the physical AI. Do you recall that we just invited several folks from the NVIDIA, so including Spencer, people in the Guru team, and then Near team, and then also physical AI related teams. And we started some relationship with them, and then we had some other checkpoint in the Santa Clara. And at the time also, and then after that, we just invited several folks to our office, and then we shared what we are just building this, but because we are focusing on the human data pipeline. NVIDIA team also just had a great interest on it. So that we now just formed some quite, maybe around maybe 20 people task force together. And then, maybe getting benchmark on paper is nothing, right? So we need to create some certain benchmark framework that can be used to many different ecosystem partners. We are building this kind of DexBench on top of NVIDIA's Isaac Lab Arena. But anyhow, we are working with that kind of collaboration with NVIDIA. So we are working with Isaac Sim, and then Newton, and then Arena, and then also just to maybe tackling on some very top challenging some parts. For example, maybe getting some proper simulation assets. There's like a very irregular shaped object. That needs very much some context. Yeah, this is the area that even within the NVIDIA Newton team really just wanted to solve these kind of areas. And then we are maybe giving some feedback to current maybe Newton, and then we are just sharing their kind of ideas. And then now we are just creating some simulation by environment to just conduct the DexBench tasks within the NVIDIA platform.
How our DexBench with NVIDIA in real world, how do we have to emphasize in terms of there's so many benchmarks coming out?
The ultimate goal is we'd like to just maybe simulate some real world environment in a very precise way, right? While we are just working on this journey together with NVIDIA, I think NVIDIA introduced several very fantastic startups to us as well, because in the simulation field. So that creating simulation assets sometimes requires some another level of the physics behind that irregular shaped object, and then maybe some tasks like the precise insertion, right? You need make some lots of different just context, so that we need some partner to create that kind of very detailed level context-rich simulation assets. And then also, so deformable object is also just another difficult story. So that NVIDIA introduced several just startups that we can just partner together. And then we are just solving this kind of the problem together with NVIDIA.
Together.
Yes.
I think that's very important because, this making a benchmark is very hard at first. So it is very interesting that many different companies are working together.
Right.
We're already building the ecosystem, right? I mean, around this the DexBench. And also, after we build the right simulations for our DexBench, then, we really expect the ecosystem around this can grow faster.
I think an ecosystem is like a key, maybe a very important keyword for the physical AI upgrades. So that we are partnering very seriously with NVIDIA and then also AWS on the deployment area. They are creating really great just platform and then ecosystem in the market. Because for us, we need partners, right? To capture data, we need better vision sensors and tactile sensors and then to deploy hardware, right? It's all about the durability. And then if we can just provide some certain framework that everyone can just look at in the same direction, right? And then understand some what's the really just the important problem through this kind of a DexBench effort, then that's the maybe ideal situation that we can imagine.
So now we define the benchmark, we put our effort to demo. So, but doing best in benchmark and demo is quite limited. It's not deployment yet. But what do we have to do for our deployment as a deployment as a North Star? What do you think we have to do better in real world?
So I think this is like a topic for the another maybe podcast series, right?
Yeah.
So we have the bunch of stories on behind that, but yeah, we need to like many different stacks, right? So the one area that we are collaborating with like AWS is like maybe cloud-based infrastructure, right? So we are now just talking about how we can separate some maybe this kind of the RFM tasks into two different right the areas, the edge computing and then cloud computing. And then cloud computing definitely have some advantages to connect with like their legacy system and then understand right different stuff, etc. So that this like just maybe some one small area for the whole maybe deployment journey. So that that's why actually just we developed a deployment team from the beginning faster than anyone else in the market, while they're just only sort of focusing on creating some frontier lab and then developing some model. We actually just started this kind of a deployment journey together with like this model development journey. And then now we are just building some product that can just fine tune based on the real world data. And then we are just putting all the different just the data recipe and the data engineering know-how into that product. They can just fine tune faster, right? So this is like one technological stack. And then also flip orchestration, right? And then safety framework. So there are a bunch of different just areas we need to tackle.
Another thing on top of what Kato was at, we should consider the overall tech maturity.
Tech maturity.
So what we've found like by building RLWRLD 1 was that there's a lot of opportunities and a lot of possibilities, but also there's some limitation with current technology. So actually, for deployment, finding the right technology for deployment is the key. We shouldn't just stick with like one technology, and we should maybe combine, or we should find the right technology for the right work site and the right environment. So of course we have our tech roadmap, but for deployment, it should be more flexible. It should be more reliability, speed, and robustness. Those are the things that really matter for deployment. And in order to achieve it, we should be more flexible and more open-minded. And so we have this whole roadmap, like according to the human race's, tech maturity. In case of autonomous driving, 10 years ago, they were saying that 3 years later we're gonna have like a full autonomous, but that didn't happen. That didn't come until now. Foreseeing what's gonna come, like when it's gonna come, is very important. So that's like actually built on our roadmap, and that's why adopting the right technology and understanding the evolution of technology is very important for deployment, especially.
So as a model company, so we laser focus on models, but we have to deal with the hardware too, and also softwares around the model. So I want to ask, what is the bottleneck? Is it hardware or software? What do you think about it, Henson?
It's my view, not the company's view, but I think for now, like a software is a bottleneck. Of course, there's a lot of room for hardware to be developed, but manipulating the fingers and the arms in the right manner, the human race hasn't not solved yet in a more detailed actions, right? I can confidently say that we're going to be the first one who are going to achieve the level where we catch up the hardware's advancement.
How about you, KW?
everything need to be tackled together. So for the software side, I think that for the architecture and model architecture, especially for the backbone models, right? There are many different just advancements, and then we strongly believe with the model architecture advancing very fast. But still the data, how to just scale maybe high quality data, and then we have our just own recipe to partner with like a lot of enterprises, but our own just the data recipe is evolving very fast, right? So that our the human data pipeline and then teller pipeline, synthetic data pipeline, and the simulation. So everything is like moving faster, and then but we need to just find some more better way to scale high fidelity and then high quality data. That's what I and then Henson is like thinking of these days. For the humanoid to be able to and to create some proper some ROI, humanoid need to just work maybe 12 hours a day and then without any just maybe breaking down.
Yeah. I mean, spec wise,
Yes.
hardware is like quite ready. But the thing is that the reliability.
Reliability is something, and then also the hardware configuration, and especially right, we had some very big trouble when we need to do some live demo. So when humanoid is like bending some wrist, then we had some serious issues that it's not just accurate enough. So there are many different uncertain and then maybe unexpected some problems on the hardware side as well. Actually, that's why that we have some different series of like all hands up. We are actually just setting up the standard for the hardware in the market and then become the group friend to many different hardware manufacturers and then giving them some proper specification and the requirements that can be deployed in the real world. So we'd like to trigger that kind of faster innovation in the market because we want some faster deployment.
I also want to ask that I think we have the business milestones and tech milestones. We have achieved certain level of the robotics foundation model, and also we have partnering with like various customers, and we have like very broad ecosystem. And what do you think about what is the biggest gap between the technical side and the business side?
Yeah, I think we are the company that shrinking that gap very fast. Yeah. I think the definitely DexBench is like one of the efforts that we are putting because of that issue, right? Because we had a great level of the conversations with like top executives in those enterprises, and then wanted to give some proper expectation when all the different technology can be matured enough that humanoid can replace real just the human labor or become a good addition to current labors. So we are actually just sort of maybe reducing that gap. More important thing is like what we are doing internally, right, within the real world is like we are the partners and we have some certain some language to understand business requirement into technology development. I think DexBench is like creating very good law in doing that, and then maybe aligning all our model development and deployment and the technology efforts to serve this. I think that's another maybe some challenge because like all the scientists and then engineers, they have some certain areas they would like to just develop further, right? And then we have the certain milestone, like a short-term milestone and mid-term milestone and long-term milestone. And then we need to clearly just understand each different maybe effort when it can be applied and when it can be matured enough to commercialize, right? So that understanding clearly technology for the commerciality, technology for the future investment, and then maybe closing the gap between the future and then maybe the today. I think having some clear understanding on the kind of environment and the kind of ecosystem is very, very important challenge for the startup founders.
The gap will close very fast, and we're expecting the year 2028 will be the year of meaningful deployment. But those kind of understanding is needed, across like all industries and ourselves, and even like it's been about 4 years now, like since GPT-3 was introduced, but it is not still perfect. Physical AI will follow the same path. Yeah, it's gonna be a gradual change, and we're gonna meet the level, within a few years, and we want to be the first one and the best one to deliver that.
All right. So and also I have a like quick and a sudden question. So I think this is very like sensitive matter because when we deploy humanoids, now we can say that we are replacing human beings, but humans are humans, so this is a very sensitive issue because they're making economic values out of it. But replacing these labors is kind of sensitive, can be sensitive. So I wonder what is your viewpoint of this matter?
We are losing population, aging very fast. So if you visit maybe convenience store in Japan, you see that either the convenience store in Tokyo, there are many just foreign laborers just working in because there are not many just young Japanese generation that would like to just and they're willing to just work in the convenience store. Within Tokyo, they can just find some foreign maybe folks that would like to just work for the convenience store. But outside of Tokyo, it's not just easy to find even the foreign people would like to just willing to work in Tokyo. And then also Haneda Airport, if you just go there, that all the maybe maintenance steps, maybe in their maybe 50s and 60s, and then they having some trouble to find some young generation. So that it's not about the replacing game, especially for the Japan and Korea. It's about the filling the gap between the demand and the supply of the resources. So that's why that especially these two markets are very maybe naturally inviting the era of the humanoid. That's my feeling.
80% of the population agrees that they need more factories in the US. But 80% of them, they don't want to work at the factories. There's a huge dilemma, right? They want the economy, but these are not the preferable jobs for them. So as Kido mentioned, filling the gap, that's where we are. Once we are all free from, labors, we need to find better thing to do. But I don't think that, the time will come within 15 years. So maybe 20 years but so it's going to be on, next generation's, problem.
What's your view, Jacey?
My view?
Yeah, you just ask good questions today.
Oh, well, I really think about it a lot. So I was an engineer before.
Yes.
So I really like building stuffs by myself. And now my viewpoint is a little shifted. So then I want to do more in the high level context. And then I think that's how my interest shifts. And in the future, I think also people will shift their interests so that previous days, the software engineers wanted to build line by line codes.
Yes. Sure.
But that's quite frustrating if you have to do it all by yourself. I think these engineers now feeling great because the cloud code, these coding agents now implementing their ideas. Their bottleneck was their fingertips, the fastness of the finger or the bottleneck of their intelligence. But now the cloud code kind of things are filling the gap. I think that's exactly what kind of happening in physical AI. So now I think people will, rather than packing the packages by themselves, but they can move to kind of shift their interest into other field. Maybe that sounds kind of irresponsible, but I think that is the essential feature as a human.
Yeah, it's like a bigger topic and more philosophical maybe, but if the time comes, I think knowing what you want is a very important. Understanding about self is a very important.
It is.
So
the evaluation of robotics is very challenging, and we are now solving. What's the next step of DexBench? Maybe it can be DexBench 2.0 or maybe different area like deployment. What do you think is the next our challenge in robotics?
I feel like a DexBench is just a starting point, right? So we set the problem through the DexBench, right? That everyone should just solve. After DexBench, what we really just wanted to is we'd like to engage in some more hardware and then ecosystem partners in this area. For example, we need to just define what's the best hardware configuration that solve this kind of the problem? What's the best set of the hands? And then what's the maybe a standard vision sensor or tactile sensors, right? And then we need to define that together with like the hardware and then the sensor companies together. And then next level of the DexBench, yeah, you know, to deploy humanoid in the real world situation requires a lot more details. Right?
Yeah.
Solving one task is like just a starting point. How to collaborate with like a human, and then make sure that your humanoid system is like clearly just aligned with like their legacy system, and then fleet orchestration, task allocation, right? Make sure that safety framework, right? A lot more, right? It should come, so that we believe that this is like a very good starting point. And then thanks to NVIDIA, that we are now just creating that benchmark that can be announced to the many different ecosystem players in the market. But we need the support from the system integrators and hardware sensor companies, and then domain partners in many different industry players. So that just a starting point.
So now let's wrap it up. So it was a really great pleasure to talking with you, Henson and KW. So evaluating the robotics foundation model or physical AI is very important, and we are now providing this kind of metrics.
Any feedback is welcome.
Thank you.
Thank you so much.